In this video, we're going to identify key points and axis of ellipses not centered at the origin. Given the ellipse below, determine the coordinates of the vertices and co-vertices. Enter your answers as ordered pairs, x, y. So now we're not centered at the origin anymore, and you can see we have a shift, and this would be a shift to the right 4, and this would be a shift down 6. Now, the original equation for this would be x minus h squared over, and then I'm going to write a squared here, plus y minus k squared over b squared is equal to 1. And the reason I wrote a squared underneath the x minus h is because we always want a to be greater than b. Now what that tells us, if this part, which is under the x, a squared is under x, that tells us we have a horizontal ellipse that looks like this. We have a center, and I'm going to call this h comma k. Right? It used to be 0, 0, now it's h comma k because we don't always know where it's at. In this case we do, because they give us h and k here, and I can actually pull those out. Let's go ahead and pull those out. H is actually going to be positive 4 because of the equation. It says x minus h, so h would have to be 4 there. So we're going to say h is 4. We're going to say k is equal to negative 6. Okay, because you'd have to have negative 6 to plug it in for k, which would mean y minus negative 6, which would be y plus 6. Now I'm just kind of writing this in general. We have h comma k. This is a horizontal ellipse. And by now you should be familiar with the major axis, which is going to be the longest axis. So I'm just going to write major here. And that this is going to be an a value from the center to the edge here, and then this would be a value from the center to these are vertices. And then also we have a minor axis, and for the co-vertices, we've got b is the distance from the co-vertice, or not the co-vertice, the center to the co-vertice. And so what we can do is we can actually apply some math to, it used to be 0, 0 here, and it was easy to find what the vertices and co-vertices were. It's still not too bad. We can say that the vertices are going to be, they're going to start at h, and then we're going to add a to h, so h plus a. Rewrite that. That's going to be h plus a, comma, and then h plus a, comma, whatever k is. So h plus a, comma, k, because we're not going to move from this k value. And then also we'd have h minus a, comma, k. That's how we'd find our vertices. Our co-vertices, well, we're going to start at hk, but we're going down, so k is changing, and we're going up, so k is changing. So we have h, comma, we'd have k plus b, that would be the upper one, and then we have h, comma, k minus b. Okay, we've come up with how the vertices and co-vertices, how we come up with those when we're not centered at the origin. All we've got to figure out then is, what are a and b? Well, a squared is equal to 25. So I can say a squared is 25. And b squared is 4. So if I square root this, I get a is 25. Or not a is 25, a is 5. A is plus and minus 5. And b is plus and minus 2 when I square root each side. So if we start to use these formulas to find the vertices, we would have, remember we're working with a here, and h we know is 4. So we'd have 4 plus a, which is 5, comma, k, which is negative 6. And then we'd also have 4 minus 5, comma, negative 6. And then for the co-vertices, we would have h being the constant here, so we're going to have h, comma, and then we start with k, so that's negative 6, and then be plus 2, and then we'd have 4, comma, negative 6, minus 2. So this gives you 9, comma, negative 6, and this would be negative 1, comma, negative 6. So those are the two vertices, and the co-vertices are going to be 4, negative 4, and we would have 4, negative 8. And so we have the two vertices written right here. We're going to kind of circle those. And we have the two co-vertices right here.